So do I need to load your memory banks full of the information you need first?
Well, you tell me, because remember when we said this, the first thing you have to do is get everything ready.
Yeah.
Now, this is where, when we choose between our top-down functional and our object-oriented, this is where it already starts. So if we're doing this top-down, we'd say, well, now we need to initialize everything. And so we'd write, we'd write a thing that's usually called main, the main function that runs everything. And then we'd say initialize. And we'd write a function. And then that initialize function would say initialize characters. And then it'd say initialize scenes. And then it'd say initialize locations. And then it'd say initialize. Okay. And then you would have presumably a set of files on there with the database of all the characters you want. And you can add to that. And, so if we start off and we've got 4 characters, then you go, I want 5. If we write it right, you add the relevant information that there is for a character to the database, or I'm going to suggest we use a CSV file. There's 1,000 ways of storing this. You can use SQL databases, you can use JSON, you can use XML, but CSV stands for comma separated values.
Okay.
And so you have a file, and at the top, you've got the column names. And you've got a name of a column, and a comma, a name of a column, comma, name of a column, because they're comma separated values. Yeah. And then underneath...
Like the old school way of adding tags to a YouTube video.
Well, it probably CSV. So then if you say this is a character, and this is our database of characters, so characters are going to have a name, and so the first column is name, and then Pete, Steve, Mary, Margaret, whatever, and then what's the next thing? And then so you just have a file, and it's a text file written in ASCII. There's UTF-8 and other things, but we'll at the moment we only need ASCII, and you know now what ASCII is. It's just a bunch of these characters, and it's a file. If you looked at each character's 8 bits, and so you just have a series of characters, and in Python there is a library, or more than one, read CSV, and there's Pandas, which is a really good tool you can just plug in, and you just say read the CSV, and it'll open it up, read all these things, and now you've got all this stuff accessible, and you can use all that data, you can change it, you can update it, you can manipulate it. We don't have to write all that.
Okay.
But we need to know what. So if let's just, before we even write anything down, okay. You're about to start playing the break, and you're explaining to me what we're going to do. How do we start?
Okay. Well, my gut instinct is that we start by giving you the
if this was a board game,
things. Yeah.
If this was a board game,
yeah.
Would you have to set up a board now?
You would have to set up the board.
Well, let's set up the board.
All right, let's set up the board. Okay. So what's on the board? The board you need locations.
Okay.
I feel like I'm doing it wrong.
No, you're gonna have to
Okay.
It really doesn't matter if you're doing it wrong.
It's true.
Don't be too paranoid. Just say.
Fail early,
imagine that Dael has gone into tabletop gaming, and it's Dael Tabletop Games Incorporated. You're going to.
That's what I'd call it.
Very, very rich.
Yeah, because you make a lot of money in the world of board games.
Yeah. And it must involve many different sided die. Okay. But so, if you were building this as a game that you could then put in a box and send off to people, and there's a set of instructions, this is how you play the game,
right.
Which in theory, I believe you should be able to do. I mean, Among Us, I now discovered, because Two Set Violin, who I watch.
He accidentally found out what game this is a fan game for.
I'm a muso as well, so I watch Two Set Violin. Anyway. And they played Among Us with orchestra, with small ensemble.
It was very interesting.
So, did you watch it?
I did watch it. Watch it. I was very impressed because I can't hear that they're out of place. they're playing like an orchestral piece, and then various people in the mini orchestra have been given altered music to play because they're the imposters, and so they have to play the wrong music but try to like look cool. It's fine, it wasn't me.
And blame someone else.
Yeah. It was neat.
Yeah.
Yeah.
So, you're going to... We had to have our noisy background. It's not...
Always, every time.
It's not a change...
No, it's important. It's a rite of passage.
So, what's it look like?
What does it look like? It probably looks like... The board would have to have different places that you can go to.
Mm-hmm. So that the board is your world?
The board is my world. Yeah. And on the world there are different, like, locations to visit. And there are different...
Can we pull this down and actually you draw your...
Oh, no, okay.
Alright.
Get out of here.
So this is, without that nearly causing you to have a heart attack.
It was scary. Okay, I'm just going to draw this like it is a board game.
Yes, that's what I want you to do.
Great. Okay. So, I would say, you know, say you have like 4 locations. I don't know how many we would have,
but
you know, these are different locations.
Yeah, and the thing is that we start off, but when we write it right, we put in our CSV file, which is called locations.cfg for configuration, and we write 4. You know, we write all those locations, all the column headers that we need. For the information about those locations, and then we write 4 of them to start with, and then as you develop your idea, you just open up your text file. That's why if you go SQL or whatever, it's tidier and it's powerful and all this sort of stuff, but you have to then use editors to get in and out. No, if you use a CSV, you use Notepad, it's fine.
Right, okay, yeah.
And I'm going to suggest we use VS Code for the Python interface. And it's got text editors, and it actually got, there's all these add-ons, and it means it'll display a CSV file all formatted for you.
Okay.
So it means it's really easy to interact with. And so we're saying, right at the moment, this is a basic pack.
Right.
The basic pack comes with 4 locations. But if you want to buy the extended pack, the special edition, it's got another 4. And then you want to buy the one, and we add them in.
Right.
But if we write it right, we just go into the configuration file and we just add the relevant information.
Okay, great, cool. Okay, so we've got, our world, we've got our 4 locations.
So let's just write world over that. World.
Pew. World probably has just been cut off, actually. Just barely. Just barely.
I need to put my glasses on because I can't see. World. Oh no, it's in.
It's in! Okay, great. I don't know how important this is or isn't, but if it was a board game, I would have pathways between the locations.
Let's start with, because that might be part of the...
These are paths.
Yep.
Okay, just so that you know. I'm going to put little nodes so we know that these are the destinations.
Yep.
In each of those, you would have, I would have, like a couple of, characters that you can interact with.
Yep.
And then those characters would have to...
Why don't we write location, L on the top of each of those?
Yeah. Cool. And if it was a board game, then each of the characters that you can interact with would have like a character card that would have on it.
Stop saying if it was a game.
Well, it's how I have to.
No. Stop saying because just if we're going to play this game,
right.
And if we're going to play it on a piece of cardboard, it's really the same as if you're going to play it on a computer.
Right.
This is working out the
algorithm.
algorithm.
Because it's a social game,
Yeah.
Each character has a character card in this very real thing.
Yeah.
There's like likes and dislikes essentially.
Presumably the characters have got a name.
Yes, they do.
As an identifier to it.
Yeah, so it would be like these are their names.
Yep, that'll do.
Yeah. There we go. Cool. And they all have those. And they would also have, I'm going to say it, you're going to hate it, but I'm going to say it, if it were a board game, they would have little tokeny things that they would like gain or lose.
Alright, so
that you
put
would put on
tokens.
that card. So tokens, they've all got those. What else? What am I missing? What am I forgetting? Where's my phone? Ha! It's underneath all of the images.
Is character starting to look like a class?
It is. It sure is, because there's 8 of them at the moment.
Yeah, and all of them have dot, 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 dot.
Uh-huh.
So remember we talked, I don't know, it didn't make it in, but we talked, you and I talked about the difference between classes and objects.
Uh-huh.
And I said that the class dog is the description of any dog. It says to be a dog,
Yeah.
you know, you're going to be stupid and eat shoes and whatever. But that's what it takes to be a dog.
Right.
Right? But then Max and Fido and Pooples are all instances of that class of animal.
Right. Yes. Yes.
So this distinction in object-oriented programming is your class is the description that you write, and then when you have C1 is an object that runs, and it's an object of type class character.
Okay.
So we're going to have 8 objects here, all of class character.
Okay.
But all the characters will be effectively the same. But then some of them are going to be infiltrators.
Yes. Oh, yes. Oh, true. I almost forgot about that, which is bad because it's the entire interesting thing about the game. Okay.
So you're going to have a Boolean flag in there.
I don't know what that means.
Remember I talked about Boolean is true or false?
Yes. Okay. Yes. Yes.
Right?
Yes. Yes.
So
yes,
you're going to have a flag in there that says infiltrator. Right? And it's going to be true or false. So that, when we get into the program, is going to be type Boolean.
Okay. All right. Okay. And if they've got a thing that
And likes is going to be a list of things.
Yes.
And dislikes is going to be a list of things. And tokens is just going to be a count.
It's just going to be a count, yeah, just a number.
So this, remember I was talking about types? Tokens can be an integer because you don't have 2.5 tokens.
Right.
So real numbers have got decimal points. And remember we go back in binary, you've just got a lot of noughts and ones and you have to tell it, these mean this, right?
Okay.
So you're going to have a type int.
Which looks an awful lot like integer.
Right.
I know how to spell. So
And-
that's an integer, this is a list.
And funnily enough, in Python, there is an object that they give you called a list.
Oh!
So we don't have to write the list.
I don't know how to spell Boolean. I took a stab.
Boolean.
I did it very wrong. Alright. And if we've got a Boolean for whether or not they are infiltrating, we also have a Boolean for whether or not they're dead, right? Because...
Yep.
Cool. Okay, so dead.
Well, yes. We'll start with that.
We'll go with yes for now.
We'll go with yes. We'll see how that plays out.
Alright. K. KKK. No, not KKK. Okay. I've learnt a valuable lesson here today about...
So far, just if we're doing this object-oriented, I think we've decided we will, and there goes the truck again, we've got a class world, and we're going to only need probably one of those.
And we've got
Class characters.
class characters.
And they're going to, and a world, so a world has locations, and locations has characters.
Okay, interesting. I think based on that, in a broader scope game, then the locations would have scenes which have characters, but for doing just a very simple version of it, you can kind of cut that out because you don't need to worry about.
Well, why not include them?
Okay, all right.
Because if that's what you want, where you want to go,
all right.
So we may as well build the system from the start.
Yeah, because the locations would at different times have different scenes, right? So like as you're going through.
Okay, now describe the difference between a location and a scene.
Well, so the location is going to be very simple. It's going to be like, I'm going to go see what's happening in the kitchen or whatever, right?
Mm-hmm.
But what's happening in the kitchen will be different in the morning compared to at night.
Okay,
example, right?
But then is a scene an object? Or is it a series of actions?
It's certainly a noun. I don't know, because it would be like, so the scenes are basically going to be whatever the conversation is and what characters are there. So it's going to change what characters are there, what menu is happening, things like that.
So, but does a scene emerge in a location?
What?
So you've got a location.
Yeah.
And then the scene is made up of, okay, so in there's characters, and whoever, depending on who the characters are, that determines what the scene is like. But the scene in that case is the interaction between the people.
Yeah.
And then they might be making bacon and eggs in the morning, and they might be having some pancakes in the afternoon or something.
Mm-hmm.
But that's what they're doing.
Mm-hmm.
So the scene feels at this stage like, how do you put a scene on there as a class? What makes up a scene? A scene is made up by characters, but characters are already in the location.
Right.
So how is a scene different to a location in that way? Locations are places that scenes play out.
Yes, that is true.
But the scenes are not an object. Don't feel like an object to me.
Right.
They feel like interactions.
Right. Yeah, that makes sense. But then how do you, if the scenes aren't the object, because to me a scene has more in it than a location does, if that makes sense. Like a location isn't doing anything, obviously.
No, but what is a scene?
Because as far as I'm like looking at it, the location does nothing.
Mm-hmm.
And will never do anything, like mechanically.
But characters do.
It's just an image and there are characters in it.
Hmm.
So then, whereas a scene is going to be like, it contains... I'm not fighting you, I'm just trying to understand.
No, that's what I want you to do.
Whereas the scene is going to have, like, I'm trying to think of some good examples. So like, you're going to have an introduction scene, which is, go to the kitchen and meet these characters, that's one scene that could play out there. But then later on there might be a scene that is the murder scene in this same kitchen or whatever. I've forgotten where I was going with this in the beginning, but it was something about why...
Well, you're saying that locations, that at a cut down version you wouldn't need scenes.
And if that's the case, then they're probably not important at all, are they?
Well, no. But I mean, what I'm trying to work out, based on this, is it feels to me, as you describe it, like the algorithm is a scene.
What? Wait. Ooh. But then, how would you make sure then that it is playing a different scene that is appropriate to the situation or whatever? Like,
all right, so
because like if the class is location,
I think what we need to do,
the location and the scenes are the different scenes. How do you make sure that location with those characters is going to be a different scene?
All right, so a scene might be an object, but it really seems like a set of parameters that you use to set up a location. So a location can load up parameters to set it up for a scene. It feels like there's a real blur. Remember what I said?
Actually, you know what might be helpful, but yes, keep going.
You remember what I said? when you start with this, and we I just wrote character and this and that and the other and world and whatever.
Mm-hmm.
You remember I said that you start off and something seems like a really obvious thing and it seems to really work.
And
then you try to do it and go,
right.
And then other times you find yourself going, of course, we need a...
Yeah.
Didn't even think of that.
Right.
This is where this becomes obvious.
Very interesting. Okay, so this may or may not end up being useful, but because I wrote a little sample scene a while back that was like, well, this seems like it would be a situation in which you could kind of...
Why don't we play it
cover
out?
all the things. Okay, because, yeah, it's basically like...
Let's just run it. This is our computer and we're going to run it.
Cool, alright. So, game starts up.
Yeah.
You are given a written explanation that's like, you're the captain of a space crew. There's a mission. Go meet the people.
So, now there's something that's interesting.
Mm-hmm.
Is there's a character which you inhabit.
Yes.
And are they different to the other characters?
Yes.
They have privileged information.
Yeah.
And they have the ability to make choices.
Yeah, and you don't have you don't personally have a running total of how much the other people are getting along with you. That's on the other characters.
Right. But but you, as the character that you are, will have it be. So we talk about we've got our parent type, and that's character, and then we have two inherited ones, and so there are behaviours and attributes that all characters, you and everyone else, have, but the player character is going to have some extra beyond.
Interesting. See, because in my head, I would have just split it up more. I would have, like, rather than having them both be character, I would have been like, these ones are characters, this one is the player. You know, like, that's how...
But if you look, that player is going to be engaging with and in the same world and have to do the same things, but it's just you're going to have some access to it. And the players, the other characters, they're going to have inside of them all of these things, but they can't see yours and you can't see theirs.
Well, but the interesting thing is that for a lot of these things, the player character doesn't need to have them. Like, you don't need to have a list of likes and dislikes for your character that you're playing, because you know what you like and don't like when you are clicking things. Like, you keep that in your brain.
So instead of there being, these characters are going to have likes and dislikes that they're going to load up from a database, a CSV file.
Right.
But your character doesn't need those, because whenever it comes around, you get offered a set of choices.
Yeah.
And they only respond according to what their predetermined, preloaded things are, whereas you get to make your own decisions and decide for yourself.
Yeah.
But you can see how you're a character and they're characters.
I can, but you're so different, because you know that you're not, like, you don't get this because there's no chance of you being the imposter. You don't get the chance of dying because you have to keep playing the game. You don't have the tokens because they're all measuring the tokens themselves. You don't have your likes and dislikes because you're keeping them in your brain instead.
Okay, so
you won't have an image because you are...
So your character, the reason why I'm thinking about that is you're going to have to interact.
Yeah.
And they're going to have to interact.
Well, they're not going to have to interact, they're going to have to react.
Yes. So all I'm trying to do is think ahead. Now, you might be right. But it feels to me, as an object-oriented programmer, that characters, you're a character.
Right.
And so it feels like, you could say, look, a car is never going to have to go on water, and a car is never going to fly.
But a car and a boat will have in common... No, I was going to say a motor, and then I remembered that rowboats exist.
And sailing boats and gliders and...
A lot of things, actually. Okay, alright.
I mean...
Noted. Put a pin in it. But
we don't have to make a decision, but
it worth
feels
being
to me
right.
that you are a character and they are characters, and so we'll see how it works.
Right, okay. So game starts, you get your explanation, you're the captain, here's your mission, go meet the crew. In this version that I had written ahead of time, you get the choice of going to the lab, the security office, or the launch pad.
Alright,
So let's call this one lab. Let's call this one security office. Sec off. And this one is I'll call it hangar because that feels like it's shorter to write.
Alright, so we want to be starting to note here and emerging. For this to even begin, because we're writing objects and they have constructors and destructors, so they can initialize themselves. So you say, give me a world, and that world, in your main routine, whatever, how we structure it, the initial place where it comes in and it runs main, that's the standard thing. Then main, the first thing it says is, give me a world. And so you've got a class world.
Yeah.
And it calls class world, and world says, now I'm going to need locations. Now, but does it load all the locations, or is it just this time around when it says give me a world and give me a world with these locations? You might specify the locations that you want, or they might be randomly chosen based on. You say give me a world with up to from 3 to 7 locations.
Right.
And then it might then say, well, here's 20 locations, because it's a big ship, that are in my... So I'm going to randomly load up 7 of them. And so now it then produces a menu, and it says, and that menu can, in our case, just be printed. Select from the following locations. And 1, lab. 2, sec off.
Sec off, security office.
Yeah.
Sec off.
And 3, hangar.
Right.
And that's so it would just.
So these are becoming a class as well, right now.
Yeah, they are. So there are locations. And so give me from, you might say, you might first say, how long do you want? Do you want this to be a quick game or a long game?
Right.
And if you say quick, then it says load 3 scenes. And if you say I want this to be a more complicated long game, and say load 20 scenes, and it may not linearly go through all of them, but it's got those to choose from. And at key points you get offered, and now because of this time around...
You know what's interesting is the difference between a location that contains a scene versus a scene that contains a location. Because you could, like if you were structuring it like a TV script or whatever, you would be like, scene, lab, day, right? And so it would couch it within that, whereas I've been framing it as, here's a location and a scene happens within that location. That I don't know whether that is important at all, but it is something.
But this is how we get, and I'd like to point out to the young and enthusiastic, I want to get some code written people. No judgment. But can you imagine if we sat down and tried to write something
without having...
And we haven't done this.
Yeah, right. Because already we've had 2 little points of like, ooh, that's going to be interesting.
Now, instead of writing, how many K-locks of code, 1,000 lines of code, K-locks, and then going, oh, hang on, that doesn't really work.
And having to go back again. Oh, nightmare.
We're doing it here.
Right.
And so by the time we actually sit at a computer, we need to know how this works.
Right.
And how it plays. And then we write the code once and then see it doesn't work. But we've got a good chance.
Right.
Whereas if you go in and you start writing and then you've got all these attributes on a character, that doesn't even work. Let's try and play it. Right, keep going.
Okay, alright. So then you make your choice, and I'm going to say we go to the security office just because...
Do we need to have a sticky that's the sticky notes are characters.
Oh, we can do that. I wrote the characters. I pre-wrote the characters.
Oh,
with,
all right.
With likes and dislikes.
All right. So get your white blue tack.
My white blue tack. Okay. Now, if we were to go to the security office, I happen to know that the two characters in the security office are orange and purple.
Right.
Those are their names. Okay. So let me see. There's purple. There's orange. Here's some I prepared earlier. Okay, so if we stick these up here. Ha! Hope that it stays. I do not know if it will.
If it does, please don't die.
Okay.
It's only cardboard, not a bug.
Now what I did here, which maybe was leaping ahead of it, but I gave values to their likes and dislikes. So I have a big like and a small like and a big dislike and a small dislike.
Yep.
That are, 2 points, 1 point,
yep.
-2 and -1. Okay, so you go there and...
So do you need to be a sticky note or something?
Maybe. Oh, because I'm there.
Okay.
I will be a sticky note, and I will be in a different color. I will be in green, because I like green. Okay. Me. Great. Love that. Love that for me. Ha 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 ha. Ha! I am
Just
in the security office.
Yep.
All right. Now.
So, recap. We've started the program, and main has created a world, and it's loaded up from a set of options. In this case, 3 scenes: lab, security office, and hangar. And then we have at least two characters which are loaded with these from our file. And yeah, we'd have these, we could add them, but we don't need to. But basically, there's a character.
Yeah.
And then whether that
we can assume that neither of them is dead yet.
And when to start?
You know what I should do, actually? Wait, are we in the process of playing the game now?
Yeah.
Okay, wait, where's I did bring somewhere here. Pew, pew, pew. I don't know where I've put it. Must be over there. My dice! A lovely little bag of dice. Because we need to know whether, I need to know.
Yeah.
Or the computer needs to know. I, as the player, do not need to know yet. But you, as the computer, do need to know who's an imposter.
Oh, yes.
So, haha, do I have a D6 in here somewhere? Pew, 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 pew. Okay, great. So, wait. These are up there somewhere. Alright, so if we say C1, C2, C3, C4, C5, C6...
And they're not.
They're not, they don't exist. Alright, so the first imposter is C4. Oh, okay, so purple is an imposter.
Alright, let's just
we'll put a thing on.
And write a big blue eye on that.
Alright.
So that the purple, did you say?
Yep. And the second imposter is, I rolled a 4, so I imagine the computer would roll it again. Another 4. What is up with this dice? And C1.
Well, yeah, that's right. It'd keep running until you'd have a loop and...
Yeah.
Yep.
So whoever's in the lab, C1 would be an imposter as well. So let me just do this so that it's over there, but it's not. Yeah, anyway. Okay, great. So, this would have happened at some point also. I don't know at what point it would have had to have happened, but presumably before they loaded the characters.
Well, as we go in here, then the world, probably, I'm going to say, probably part of the setup. You want, before you start playing the game, so you come in to main, and then you create world. Well, what's it going to be like before you do anything else?
Right.
You're going to want to have the scenes, the characters, their likes and dislikes, and you're going to need to know who the imposters are.
Right.
So as part of loading the world, the world decides based on some. There might be maybe random or might not be random. You're the game creator, but there is some way that it's decided how many and who the characters are in each location. And so when it comes into the world, it needs n. We talk about n because it's not 4 or 3. N represents a number.
Yeah.
There are n characters in worlds, at locations.
Right.
So
In worlds.
There's going to be one world, I think we're saying. The game happens in one world, but that one world has n locations, and each location has n characters with a total number of characters of n.
Right.
In a lot of things we talk about, in logic you talk about P, Q and R. In counters when you're looping, it's I, J and K. They're sort of standard letters that you use to represent things in programming.
Gotcha.
But we're going to have that. So now when the world is created,
It's just like when the paper.
no, it evolved. We can take a very long time to start this game because it has to evolve.
Yeah.
We create the world, and then in our constructor, when we construct the world, we're then going to say, well, we need to. And so we have parameters, and then when you pass in the world, you might say one of the parameters that you pass into the world is short, medium, or long, or whatever, and that could have or they could have game length, and it has a number assigned to it from 1 for short and 10 for long, and then based on it, and then you come in there, and if game length is less than 3, then have this, 1 to have 3 to 5 locations, and it'll just choose randomly, or you say have it 3.
Yeah. Okay.
And then, or if it's greater than or equal to 4 and less than or equal to 6, then there'll be this many, and if it's greater than or equal to 7 and 9, whatever. And so you have these scores, and then inside of that, it will then create in locations.
Right.
And then also based on that and the number of locations, it will create from this many to that many characters. And it'll do it randomly, so it'll read in the whole thing, it'll get them all, and then it'll just randomly grab that many of them.
Right.
And then it'll put them either randomly or not randomly into locations.
Okay.
And now we're set. It comes back to main.
Right, and it goes, hey.
And now,
ready to play.
so you say, give me a world, and by the time it comes back, all of that's done. So one line of code down in main gets all of this ready. But then by the time you do, this is read files and opened them, and it's so the world has done that. And then each of the locations, maybe you may delegate to the locations to decide how many characters.
Right.
And so then you end up with these characters in these locations for whatever you may. The world may decide the characters and where they go, and then pass into when the locations are created. They're created and they're told, make yourself, and your characters are these.
Yeah.
And or you might have it so that the locations create the characters. I'm thinking probably the world passes the locations of characters, because you might want to do that. But it could go either way.
Right.
So this is where you have to make all these decisions about how this is our algorithm.
Right.
So now, by the time you say, you know, you want a world, and the world does its things. One way or another, it comes back, and all of this is set up.
Right. It's like the setup stage of a board game. It's all pre-prep. Okay.
So you'll before you start playing the game.
If you play a game of Mafia or Werewolf, then before you start the game, you decide who's like.
And everyone gets so much money, and
yeah, you know, okay.
And they choose whether the shoe or the hat or whatever in Monopoly.
It really is a video game. Okay, cool. All right.
Is this sort of...
It makes sense. It does. Cool. So then, all right. By the time I get here and I'm meeting these characters, I don't know, but the computer knows that this one's an imposter. It already knows that it's locked in. They've got the little true flag next to them. The Boolean.
Yeah.
Boolean flag. All right. Cool. So then you get there. And you have your little intro conversation, and with each of them, what I've written it as is a 2-point convo, which basically I just mean that I would have like 2 different moments in the conversation where you get to choose from, you know, N options. I don't know where I put the black one.
All right, so this is where scenes start to...
This is where scenes start playing.
And we have to decide... at some point, not yet, but we have to start thinking about. So there are characters in location. Now, are there predefined scripts that you can draw from, or are there a set of random interactions?
Predefined.
So where are they defined?
Where are they defined? That is an excellent question. Because that's going to be what scenes end up being, isn't it, really?
Because I don't know. I'm a computer and I don't know.
Right, you don't know. So I have to work that out. But I'm also thinking ahead to the fact that these characters are going to be moving location and still having scenes. So are locations within scenes or are scenes within locations?
Okay, so clearly then we can have it so that a character can change locations.
Yeah.
So you've got a class and it's got a list of characters, and then at some point you can say to this character is going to move to that one.
Because it would all be predefined scripts. It would be like, okay, introduction stuff. You can choose where you go, you can choose what you say, but like when you choose to go to the security office, this is the conversation you will be having. When you choose to go to the hangar, this is the conversation this is the scene that will play out. And then after that, it'll be like, everyone meets up in the hangar again, you know, but now all the characters are there and it'll have a different preset.
So obviously then, locations are going to have a list of characters that are in that location. And so if you want a character...
And it can change.
And so what you can do is you've got your list of characters, and then you could have an operation in your world to move a character from one location to another. And so what it does is it said to this location, you no longer have that character, and that character then gets passed over.
But then how do I make it call a specific scene? This scene thing is really what's going to kill me, clearly. Like, it's good that we're doing it this way rather than just because the scene thing has me messed up.
Isn't this more interesting and less frustrating than staring at
I think so.
An interface?
Definitely.
We need to know this before we write a single line of code.
Wait, I need more paper, but this is okay. If I roll that down, will it drop everything off it? Okay. I'm gonna try it.
And then we can wind it back up again.
Yeah, we can try winding it up, which is something we have not done yet.
No.
In my brilliant invention. Wait, come out.
You've got from there down.
My arm got stuck behind the couch. Couldn't bend. Alright.
You've made some very good noises so far. None better than when that piece of stuff fell off the wall.
I was afraid. I don't like bugs, especially ones that fly. Okay, that's good enough for now. Alright, great. Okay, because I just want to be able to write out my thoughts, because I always think better if I'm writing it out.
And this is heading to our algorithm.
Okay, so I just want to understand. So if scenes are the big thing with locations in them, versus if locations have scenes. I know that you're like beyond this, but I clearly am not.
No.
I need to just think it through.
We're trying for you to write this program,
right,
not me.
Exactly. So if scenes are in locations, then you can, if with a pre-written thing, you can be like, okay, it is worded as if you were choosing between locations, but really you're choosing between scenes. So you would be like, here's scene lab intro, and within scene lab intro you have C1 and C2, and you know their dialogue and all that stuff. Blah blah blah.
Are you thinking what I'm thinking, C1?
And you would also have, you know, scene hanger intro, and it would have whoever it has, C4 and 5, or no, whatever it is, you know what I mean? C5 and 6.
Yep.
And they have their stuff. Whereas if we do locations with scenes in terms of pre-written stuff, then the locations have characters. Is that right? Which then have scenes, which are the dialogue. So the dialogue becomes the scenes. And then when you change location, this one would just move on to, like, a specific trigger would be like scene, hanger, murder. Whereas this one would be like location, hanger, but the characters have moved. I'm still confused. I thought this would help. I thought it was helping.
No, it is.
Is it?
You just don't realise yet.
Do you realise?
I'm a computer.
No! Computer, help me! Can't I give you an AI that talks to me like in the movies? Because wait, okay.
Well, see, now we're teasing out. What we're trying to explore here is we've got objects and we've got an algorithm.
Yeah.
Right? And so I am feeling, without being confident of it, that these scenes are the algorithm.
That the scenes are the algorithm. Okay. But I don't understand. Because to me, on the surface of it, it looks like this would be more rigid but easier to implement, whereas this one would have more flexibility but would be trickier to implement.
Well, I don't see that as being particular. I mean, nothing about moving a character from one location to another is hard.
Okay, but like, it just seems like it's dividing it into more pieces, if that makes any sense. So this one is like, this is a scene, preset character, blah blah blah. Whereas this is more like, here are the characters.
Okay,
here
but
are
if
stuff
you do,
they can say, here are locations they can be in, and they can all move
but
around.
if you get there, then based on a random thing of who the imposters are,
yeah,
and presumably a random thing on who gets murdered,
yeah,
the next scene has to get that information passed on to it.
that is true. That is true.
And if you've got them already locked, how do you incorporate the fact that every time it comes in, the story unfolds?
Right. Okay, that makes sense. Because then that means that this, like, going hardcore this the whole way through would end up in that problem that I mentioned. I don't remember if it was off camera last time or on camera, I don't know. But I mentioned at some point in discussion the idea that once you have to start planning for every different possibility, it becomes really tricky.
Yeah.
Okay, whereas if you just have it and it's flagged and it's like, this character is an imposter, then...
Now, actually, at about 1:45 a.m. this morning, I started... this is where implementation matters. And the fact that we've found this before we've spent 6 hours writing is fantastic, and why we do this. But there was, all right, this is just an explanation. This is going to be several videos, we can tell.
It's much less friendly when it's got the stuff you attached to it.
Worst come to worst, we can recap it. All right, so I had an instrument, and we have 4 inlets, and so there's a line comes into each of those, and then that goes off, and then there's air comes in, flows through there, and then there's a valve here, and we can bypass a cell, and there's a cell in here, and there's a valve. So these are 3-way valves, and then the air can go out and up, and there's a pump, and so, but there was 8 valves in this system, and I wanted to have an animated display for the user, where it would animate the flow of the gas through this system. And there was a finite number of valid options. So what I did was I used effectively 8 bits. So I've got 4. Alright, so here's our mem. And this is valve 1, 2, 3, 4. These 2 are ganged together, so they were 5. And then there's a valve here, and that's 6. But there was 8. So I say that this one is 1, 2, 3, 4, 5, 6, 7, 8. That's the valve number. Now, each of those valves can be opened or closed. So we now have, it can be on or off, right? So then, I now know that with those 8, because I know my binary, I know that there's 256 possible states.
Okay.
And if you turn, if I check and valve 1 is on, I treat it as a binary, and I add 1. So I can have, out of this, with my valves, I know that I can have 0 to 255 as a value if I just do that as a byte, treat that as a byte. So if I look at all my 8 valves, and I load the state of 1 into here, is it on or off, right? Then I know, by just treating that as a byte, and looking at this binary value, converting it to decimal, I can immediately determine the unique state of this by that number.
Okay,
But then I table up in here, I'll just use a spreadsheet, and I went through and I went, okay, valid states are valve 1 open and these, or valve 2 open, 3, 4, And so I went along and I went tick, 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 cross, cross, tick, tick, for the 255 states. And the vast majority of them were crosses.
Right.
And so people could, from my software, there's a form here, and there's a bunch of buttons, that you click, and there's 8 of them. And if they click them, they can manually open and close valves.
Right.
So they're wanting to set things up, right? But if they open that one and that one, it's bad. We don't want that. So if they go like that, every time they click a button, I just check this value against this table. And if it's not a valid value, then on my animation, I just turn it red.
Right.
And it just straight away knows that the computer, bam, immediately it goes red.
Right.
But if I hit any of a certain set of values, then I know, okay, if it's in this, draw this, animate this path, animate this path. And also it meant that I had a list of all the valid ways you could use the instrument, and a drop down And I named them. So sample from inlet 1, flush from inlet 1, whatever. And you could just click on a drop-down box and go, I want to do that. And based on that value, it would immediately know all the valves to set.
Right.
And so the user could then, rather than having to remember, I need to open this and do this and do that, they just go, I want to measure from inlet 1.
Right.
And it would...
Okay. So rather than having to check every individual thing...
And run down to the bottom line. Now there are finite state machines, which I won't talk about, but there's all these algorithms that allow you to deal with these sorts of things.
So basically you're promising me that moving a character won't be tricky.
Well, what I'm saying is that if you want to do this, you need to do something...
but it's actually...
You need to do something like this. But then, by the time you've got 8 characters and 4 scenes...
Yeah.
And
the randomised...
And then the number of ways it can run.
Right.
The number of... When I only had 8 valves, I could deal with 255.
But if I've got 12
programmatically...
characters, yeah, okay.
It was really not that hard to write because there was, I don't know, there was maybe 20 valid ones and 236 invalid ones.
Right.
And so I could, and it was a really fast way of, because this machine, this instrument, is a very, very tightly controlled set of meaningful states.
Yeah.
And so this worked, and it took me a little while to go through, but most of the time you go, well, that's wrong, that's wrong, that's wrong, right? And so it took me an hour or something to draw up this table.
Right.
And then I had a really quick, easy way of doing this. But I'm just asking, what would it look like to cache out this and replicate something like that programmatically, as opposed to letting things evolve? So now wind it back up again.
I'm a genius! So pausing on this particular one for a moment.
Yep.
Because with what you just said in mind, I think I get it now, because if I was to be like, even though I think of it as like, oh, well, it's a pre-written scene, really it's going, okay, if you want to call the scene, lab intro, I would need to then call the location, and it would need to remember what characters are in that location, and then it would need to remember whether those characters are imposters, and then it would have to remember whether those characters are dead, and then it would have to, and then if those characters are dead, then that scene shouldn't be running anyway, so it would have to go back up to the top, and then it would have to...
And if we say that there are randomised elements even in scene 1, how many permutations... Obviously, every time we add another scene, another location,
there's more.
The number of permutations is not linear; it's exponential.
Yeah. Whereas
what
this
was
one,
that? That was an interesting response.
That was me panicking at the thought of trying to figure out exponential stuff. Whereas this one, you call the location, you call the character, and you go, okay, well, this location at this time,
and the character comes in.
Location at the time of intro, has these characters, and those characters have these traits, and then you go to the next one. The next time you come back, it remembers whether those characters have those traits or not.
Well, no, the characters...
Because they stay.
The characters
move around.
Yeah, and so you've got a character, and internally it's got all the states.
Right.
And you say, all right, now this character is going to go from this location to that location, but all of its... Yes. Why do I feel like poking you in the ribs?
How dare you? I summon thee from the depths. I can't believe nothing fell off.
We should have some sort of music.
It's still there.
There should be some kind of a theme or anthem or something. So, this character, you can just unplug that character with its current state.
Oh, which is very, it's a handy metaphor, because I can unplug it and I can just move it to the hanger.
Yes.
Hey, neat. I did all of that writing and I could have just imagined.
Well, no, it helps you think through.
Yeah, it absolutely did help me think it through. Okay, great. All right. Now that I've, come to terms with that little moment of nearly existential confusion,